Hello everyone. So in this video, I am going to explain a optimize section in transformation. So optimize section is available in all kind of transformation, either source, filter, sort, or any kind of transformation. So let's understand optimize section. So in the optimize section, we have an option called a partition option. So what is partition option? So let's start. So partition option means we have to define how data should be distributed on a different nodes. Okay. So the first option is current partitioning. So in the current partitioning, we don't need to define how data should be distributed on different nodes. It is defined by cluster can say system automatically. It's already predefined. Now the thing is, should we change this current partitioning to another kind of partitioning called single partitioning or set partitioning? The answer is it's depend upon scenario. Okay, so when we try to change the partition type from a default option called use current partitioning to any other option like a single partitioning or set partitioning, we may see performance issue because what will happen when we change the partition type, then repartitioning will happen. So this will take time. Okay, but still we may have a scenario where we can change our partition type. So we have a another partition type called a single partition type or set partitioning. Okay, so let's start with first a single partition. So what happened in single partition? In the single partition, just assume we have this data, okay, this row, and we have a three partition or can say data is distributed on three nodes. So if we change my partition to single partition, what will happen? All data will be redistributed to one partition or can say on one node. Okay, so all will be redistributed to one partition. So this may reduce the performance of our data. The first thing, repartition will happen, so this will reduce the performance. Another, all data is on single node, so again it will take more time to perform any kind of operation. Now the next thing is set partitioning. So when I click on set partitioning, I have a 1 2 3 4 5 options. Okay, so let's see one by one. The first is the first partition type is round robin. Okay, so what does it mean? So just assume if I give a partition 3, so what will happen? My data will equally distribute on a 3 partition. So just assume this is my data. Okay, so total row is 12. 2 to 13 means 12. So 4 rows will be on this partition, another 4 will be on next partition, and another 4 will be on next partition. Okay, so like that, if I choose a round robin and number of partition 3, then data will be distributed on 3 partition 1 2 3. Okay, if I change to 4, then data will be distributed on a 4 partition part 4. Okay, so again data should be equally distributed on all partition. Okay, now next is hash. So what happen when we choose a hash partition type? So and here I have selected a number of partition 2, so I can choose 3 also. Okay, and then let's select column vendor id. Okay, so sorry, now again let me come with my example. Just assume this is my data called vendor id. Okay, and if I choose a hash partition type, the similar or same type of value will come to one partition. Okay, so let's delete this and understand how the partition will happen or how the data will be distributed on different nodes. So 1. Okay, now just assume I have 3 more 1, so all similar kind of value will come to this partition. Okay, now 2, let's assign 2 here. Do we have any other 2? Yes, we have one more 2. This will come to this partition. Okay, similar type of value. So we have given 3 only partition. Okay, now let's find 3. So if 3 is here, okay, we defined only 3 partition. Now we have a 4 5 6. Okay, 2 already done. 4 5 4 remaining. What are the things remaining? Let me mark first. 4 5 6. Again 5 is there. Okay, so 5 5. Okay, 5 is done, so unmark this. So we can see first how what is happening. Similar kind of data is distributing on same partition. Okay, all 1 is on partition 1, all 2 is on partition 2, all 3 is on all 5 is on partition 3. Okay, so 4 to 6 8. Now what are the things remaining? This 3 remaining. Okay, and then 8 remaining. Okay, 2 4. Okay, so now what will happen after same kind of value goes in one partition, it will look for a similar kind of value. Okay, so I think 3 should go here. Yeah, then 4 maybe go here, and then 6 and 8. Okay, so similar kind of value goes into one partition, or can say nearby value goes into one partition. Okay, so now I just given one example, but the how does partition happen in backend, we don't know. Okay, so now what is the use and how it is beneficial? Just assume when we perform a group by and aggregate operation, this will be beneficial. Okay, so if I do group by, then what will happen? A group by vendor id, so we can see all the groups is on one partition. This all 2 group is on one partition, all 5 group is on one partition. So this will be this will increase the performance of transformation, group by and aggregate transformation. Just assume data is not distributed in this way, like one this 2 1 is here. Okay, then it has to when the group by happen for these two, then again it has to shuffle for this another 2 value that is on another partition. Okay, so this may reduce the performance, but if the data similar kind of data is on one partition, definitely it will improve the performance when we are going to perform group by and aggregate operation. Now the next is dynamic range. So what happen in when we choose the dynamic range? This Synapse data flow, or can say Azure data factory data flow, dynamically define the range of partition. Okay, just as it happened dynamically. Okay, just assume 1 to 4. Okay, will come to this partition. Okay, hold on. In the partition 1 1 to 4, sorry, 1 to 4, 4 to 6. Hold on, how many partition we are defining? Let's define 3. Okay, 4 to 6, then 6 to 8. So it happened dynamically. We have a no role, there is a no user role to define the range. Okay, let's see. Dynamic range is similar to fixed, except that system figure out the range for the column you supply. So we just need to supply the column, then range will be defined by system. Okay, I'm just giving example. So system may give this kind of range. Okay, it's not like system is going to give this kind of range. I'm just giving example. So just assume if a system has defined a 3 range, 1 to 4, 4 to 6, sorry, 5 to 6, and then 7 to, we can give anything, 7 to 9. Then 1 to 4 value will come here. 1 1 1, we have a 4 1. Then again 2 2, sorry, 2 2, and 3 will come here. Again for 5 6 range, we have 1 5 or 2 5. We have 1 2 5. So 5 5 6. So in this we can understand, like I'm just giving example, but system define the dynamic range. Okay, and whatever range defined by system, data goes accordingly to that partition. Now the third is fixed range. So in the fixed range, we define the range. Okay, so here we can see I defined the number of partition 3, and for the partition 1 I defined the range. Okay, so wherever I have a month peak date time is equal to 2, will go into one partition. Wherever I have month equal to 3, will go into the another partition, and the remaining will go to the third partition. Okay, so in this this is the example of fixed range. Now the third is key. So when we choose a partition type key, then we don't need to provide a number of partition. Okay, it partition happened based on the unique value. Okay, let's understand with example and delete everything. Okay, partition happened based on unique value, so all the unique value goes into one partition. Okay, so just assume one is a value. Okay, now 2 1 and 2 both are unique to each other. Okay, now 3 is also unique in this partition. 4 is also unique in this partition. 5 is unique in this partition. Okay, 5 is unique in this partition. Sorry, what is happening here? Okay, no problem. 5 is unique in this partition. After 5 6 is also unique in this partition. Okay, now again 2 is not unique in this partition because 2 is already present, so 2 will go to the another partition. Okay, now again after 2 5 is there. 5 is also not unique in this partition, so 5 will come here. Now after 5 8 is unique in this partition. Okay, then after 8 there is a 1 is already there, so it is not unique in this partition, it will go to the another partition. Again we have 1, so 1 is already available here, so this third one should go to the another partition. Again we have one more 1, so 1 is already present, 1 is already present, 1 is already present, so this one should go to this partition. Okay, so this is how data gets distributed when we choose a partition type key. So we should choose a partition type key very carefully. Like when we have a lot of duplicate value, in this case we should not choose this key partition type, otherwise we will have many number of partitions. So this will also degrade the performance of our data flow. So this is all about optimized section of Synapse, or can say Azure Data Factory or data flow. Thank you.